Hello everyone, welcome back to our channel. So today we will see how to create Memcached cluster in AWS using Terraform. So in this video, we are going to cover how to create ElastiCache Memcached cluster in AWS using Terraform. And in this video, we'll discover how to set up Amazon ElastiCache Memcached using Terraform. The best part is all the steps we'll cover can be done without incurring any extra cost because they are eligible for the free tier. So first we will discuss what is Amazon ElastiCache. Amazon ElastiCache is a caching as a service from Amazon Web Services. AWS simplifies setting up, managing, and scaling a distributed in-memory cache environment in the cloud. It provides a high-performance, scalable, and cost-effective caching solution. AWS removes the complexity associated with deploying and managing a distributed cache system. Amazon ElastiCache is a fully managed in-memory data service provided by Amazon Web Service. It is designed to enhance the performance and scalability of applications by providing a managed caching solution. Now, the key features of Amazon Elastic Caches are: first, managed caching. Elastic Cache handles the complex task of setting up, configuring, and managing cache infrastructure. Second, in-memory data stores. Elastic Cache supports two popular in-memory data store engines: Memcached. Memcached is a simple and fast caching engine that supports a simple way, key values data storage and retrieval. It is ideal for use cases where you need high-speed caching with minimal complexity. Redis. Redis is a highly versatile open source in-memory data store that supports more advanced data structures, such as sorted sets, hashes, and lists. It is often used for caching real-time analytics and as a message broker. Third is scalability. Elastic Caches allows you to easily scale your cache cluster vertically by selecting different instance types and horizontally by adding or removing cache nodes. This ensures your cache can handle increased workloads as your application grows. Fourth is automatic failover. Redis clusters in ElastiCache can be configured with automatic failover. If a primary node fails, ElastiCache automatically promotes a read replica to primary node, minimizing downtime. Fifth one is backups and restores. Elastic Caches provides the ability to take manual snapshots of your cache clusters. You can use these snapshots to restore your cache data or clone cache clusters. Now we will see what is ElastiCache Memcached in AWS. So Memcached is one of the caching engines supported by AWS ElastiCache. Memcached is a popular in-memory caching system used to improve the performance of web applications by storing frequently accessed data in memory. Until now, we have discussed both the caching engines, but I may seem biased toward this. So Memcache is an open source, high-performance distributed in-memory caching system. It is commonly used to speed up data retrieval operations by caching frequently accessed data in memory, reducing the need to fetch data from slower stores such as databases. So the question is, if Redis is all powerful, then why doesn't ElastiCache provide only Redis? So there are few good reasons for using Memcached. So it is the simplest caching model. It is helpful for people needing to run large nodes with multiple cores or threads. It offers the ability to run scale out and in, adding up and removing nodes on demand. It handles partitioning data across multiple sets. Now the prerequisites are: before we begin, you should have the following prerequisite in place. First one is you will need an Amazon Web Service account. If you don't have one, you can sign up for a free AWS account. Basic knowledge of AWS services and concepts, Visual Studio on your system, Arching of Terraform extension. You can download it from the official Terraform website. So now we'll start. So first we'll see how to create Memcached cluster in AWS using Terraform. So steps for the implementation for this project is, so let's start the following organizational structure as shown below. Now first we'll create a folder, Terraform Memcached. Then we'll create four files in our Terraform MariaDB: variables.tf, terraform.tf was main.tf, and output.tf. So variables.tf. In Terraform, the variables.tf file is used to declare and define variables that can be referenced in your Terraform configuration files. These variables act as parameters that allow you to customize your Terraform configuration. Second, variable declaration. This is where you define your variables using the variable keyword followed by the variable name. For example, using variable.tf file, it helps in making your Terraform configuration more modular and adaptable. By centralizing variables definitions, you can easily manage and update configurations values without having to modify multiple places in your code. It also promotes visibility and clarity in your Terraform. Next is Terraform.tf files. In Terraform, Terraform.tf files is used to store input variables and their values in a key value pair format. This file allows you to set values for variable used in the Terraform configuration without outputting them directly in the Terraform files. Next is main.tf. In Terraform, main.tf is a default and permission name for the main configuration file. This file is where you define the infrastructure resources and their configuration using HashiCorp configuration language. The main.tf file is essentially the entry point for Terraform to understand how to get update and manage your infrastructure. So now here is a basic example of what a simple main.tf file might look like. Then outputs.tf. In Terraform, the outputs.tf file is used to define output values that can be displayed after the execution of the Terraform configuration. This file allows you to expose specific information about the resources you have created or modified during the Terraform run. Outputs are useful for providing useful information or data to users or external systems. So here is the in this example, an output name example output is defined and its values is set to the ID of an AWS ElastiCache cluster created in the Terraform configuration. So now we'll create a variables.tf file in Terraform Memcached folder. So for that, we'll enter the below code. We'll copy this code and we'll paste it in variables.tf. So after this, we'll create a terraform.tf file in Terraform Memcached folder. We create a terraform.tf folder which we have already created. So in there, you are defining the dynamic values for the variables declared in variables.tf file. So we'll copy this code and we'll paste it in this folder. After this, we'll create a main.tf file in Terraform Memcached folder. For that, we'll create a main.tf file, and in that, we'll copy this code and we'll paste it in main.tf file. There. So after this, we'll create a output.tf file in Terraform Memcached folder. For that, we'll create an output.tf file. And the outputs are ElastiCache Memcached endpoint to confirm that they are created. So we'll copy this code and we'll paste in output.tf file. So now we'll initialize and apply Terraform configuration. For that, we'll open a terminal in the directory containing your main.tf file and run the following commands. Before that, you have to add your consoles and your ID. So we have to add our access key. For that, we'll go to our AWS account and there into security credentials. And from access key section, we'll create access key. We'll create access key. So our access key is created. We'll copy access key and we'll paste it in the code. Again, we'll copy the secret access key and paste it in the code. So we're done. So after this, we initialize and apply Terraform configuration. For that, we'll open a terminal in the directory containing your main.tf file and run the following command. We'll run terraform.il. By running Terraform plan, you get a detailed list of these categories. It is initializing. So yeah, by running Terraform plan, you get a detailed list of these three categories: additions, modification, and deletions. It is a way for you to review and confirm that Terraform understands your intentions correctly. So now we'll enter Terraform plan. We run it. Once you have satisfied with the plan, you can proceed to apply those changes using Terraform apply. This two-step process, Terraform plan followed by Terraform apply, help prevent unintended or accidental changes to your infrastructure. It gives you a chance to review and approve the proposed changes before Terraform makes any modifications to your environment. So we'll enter the command Terraform apply auto approve. We'll do. We have to wait for a while because it will take some time to create resources. So we have to wait for 5 to 6 minutes till all the resources have been created. Now go to ElastiCache console. Click on the Memcached. You can see ElastiCache Memcached cluster created successfully. Now our output is also created. You can see the output. After this, we'll delete AWS Memcached cluster using Terraform. So we'll run the below command to destroy resources. So Terraform destroy. We'll run it. So after this command, our AWS Memcached cluster will get deleted. Type yes. Or type yes. Now you can also check in your console. Your resources has been deleted. So this state is it is deleting. So here we conclude. In this video, we have demonstrated how to create ElastiCache and Memcached cluster in AWS using Terraform and destroyed it later, not to incur charges. So thank you everyone. See you in the next video.